Hello and welcome to the course of manufacturing technology or manufacturing method. In this course, we have already studied about casting, and this is the second lecture of module 2, and it is the seventh lecture of module seventh lecture of total syllabus. And in this syllabus, in this lecture, we will study about rolling. Rolling means in the last lecture I have discussed that there are several types of metal forming process, and rolling is one of them. So in this lecture we will first introspect about rolling process. That means what is rolling process, how rolling process is done. These things we will study. We will study about different rolling processes, then we will study about different rolling mills, and then we will get an insight of what is contact length, what is contact angle, what is maximum draft in rolling. And after that we will discuss how the rolling force, rolling torque, and rolling power can be calculated. Next, we will see about the rolling defect. Then we will see a simple numerical. So let's start. Rolling. Rolling is a process. Rolling is the process of reducing the thickness. It is a process of thickness reducing by changing the cross section of a long workpiece by compressive force applied through a set of rolls. So what is rolling? Rolling is a process of reducing the thickness. So thickness reduction process, it is a thickness reduction process. See, in this process, a form the in this process, workpiece in the form of slab or plate, workpiece in the form of slab or plate is compressed between two or more rotating rolls in the thickness direction, so that thickness is reduced. The rotating rolls draws the slab into the gap and compress it, and the final product is in the form of sheet. See, in this figure, what is in that, this is the direction of the flow, and the rolls are revolving or rotating in opposite direction, so that the thickness is also reduced, and the plate is moved in this type of roll. This is an example of flat rolling or flat roll. This is an example of flat rolling. But there is another type of rolling. That is called shape rolling. In shape rolling, the square cross section is also be formed into a shape such as I beam, L beam, or railroad shape. That is how the railroad shape is. This is the shape, railroad shape, and this railroad shape, this also can be done using rolling. Now we will see some of the typical application and of the rolling. So see, from the continuous casting or ingot, what we can get? We can get slab. This I have told you earlier also, billet and bloom. Now from this slab, this slab, hot working, by hot working we can make hot strip. Then we can make, by after making hot strip, by cooling them, we can make cold strip. Then we can make another thing we can make, that is scalp. By scalp, from the scalp we can make welded pipe. By the from the scalp we can make welded pipe. And we can make from slab, we can make plate. And if the plate thickness is again reduced, we can make this type of steel plate and or sheets. So now from the billet, hot rolled bars, rods, rods, pipes, this can be made. This can be made. Then from the hot rod bars, cold drawn bars can be made. And from the rod, where products can be made. And from the pipe, seamless pipe can be seamless hollow pipe can be made. And from the blooms, from the blooms from the blooms structural shape such as I shape or L shape that can be made, and rails or railroad, these can be made. So these are the complete process, these are the complete rolling processes. Now we will see that there is two type of the rolling, that is first one is hot rolling and second one is cold rolling. In case of cold rolling, the rolling is done in at room temperature. When the rolling is done at room temperature, what are the advantages? Closer dimensional tolerances can be achieved fast. Secondly, good surface finish can achieve. Third, because of strain hardening. Strain hardening means due to the continuous strain, due to continuous deformation, the hardness is increased. This process is known as strain hardening. Due to this strain hardening, higher strength and hardness is seen in the part. Higher strength and hardness is seen in the part. Next is grain flow. Next is the grain flow during the deformation. Grain flow during the deformation provides the opportunity for desirable directional properties. That means due to when the working, when the material is deformed at at low temperature, then there is grain flow. That means the material is inside material, the microstructure is compressed. That means that my compressed microstructure increases directional properties, increases desirable directional properties. Next, since there is no heating in the work is involved, so fuel cost, furnace cost, or electricity cost, these are minimized. So cold working is somewhat economical. And machining requirement means post working machining requirement are very minimum, so it results in near net shape forming. So these are the advantages, these are the advantages of cold working. In case of hot working, the hot working means the rolling or hot rolling means elevated temperature rolling or rolling above the recrystallization temperature. When there is rolling above the recrystallization temperature, what happens? Grains will break or crystal structure will break. What is the significance? Significance is, or the advantages is, significant plastic deformation can be given to the sample. Significant change in workpiece shape, lower forces required, and material with premature failure can be hit hot formed, absence of strengthening due to work hardening. So these are the advantages. Due to these advantages, what happen? Easy formation, easy shaping or easy formation can be made. Easy formation can be done. So these are the difference between these are the advantages of hot rolling and cold rolling. Now we will see different type of rolling mills. There are several type of rolling mills. When there is only two rolls, two rolls rotating opposite to each other, and the stock or material is between them moved between them, this type of setup is known as two high roll mill setup. Next, there is another setup, that is three high roll mill setup. For more thickness of material, for more thickness reduction, we use three rolls with if this is rotating anti-clockwise, next roll will rotate clockwise and the other is rotate anti-clockwise. That means first and third roll will have same direction of rotation, and by this what happens? The sheet is rolled through the first two rolls, and then it is bent and it is rotated through this. This type of rolling gives greater reduction of thickness. So for higher reduction, in two pass. In in two pass, three high roll mill is used. Now there is another type, that is four high roll mill. If we want maximum more reduction in single pass, more reduction in single pass, that is provided by four roll mill. In the four roll mill, these two larger rolls are rotating rolls, and these two small rolls are idler rolls. These two ideal idler rolls will rotate due to the friction between the between the rotating rolls and the material stock, and the direction will be different. So material will pass through this, and here the reduction is very large. Similar type of rolling mill can be seen in case of cluster mill, where the idler rolls are supported by more than one uh, rotating rolls. So this is known as cluster rolls. This type of setup is known as cluster rolls. More reduction can possible using the cluster rolls. Now there is another type of rolls for subsequent reduction, for progressive reduction, that is known as tandem rolling mill. Or this tandem rolling mill you can see in any steel working shop. This type of rolling mills you can see in any steel working shop. So whenever steel is processed, this rolling is a very vital operation. Now we will see the various types of rolling. First is transverse rollings or roll forging. This is also called, the operation is also called cross rolling. This is also called cross rolling. The cross section of a round bar is shaped by passing through a pair of rolls with profiled groove. See, this is a profiled groove. So the groove can be made. Roll forging is typically used to produce tapered shafts and lip spring. These are the typical use of roll forging, that are they are used to make taper shafts and lip spring, table knife, and other hand tools. So it may be used as a primary forming operation, and it is followed by different forging process. So next is skew rolling. This semi-finished ball from a rod can be made by skew rolling. In skew rolling, this type of threaded roll is rotated in opposite direction, and the stock is also rotated while progressing inside the roll, and that gives semi-finished ball sphere-like structure as a product. This is known as Q rolling. Next, rings can be formed from a rings that can and the diameter of the rings can be increased using rolling. By this process, in ring rolling, there is one rounding roll, one main roll that is driven by a motor, and one rounding roll and one idler roll, and there is two edging rolls. So according to this, this setup can increase the diameter of the existing hole in a workpiece. So the diameter of the ring can be increased by using this process. So this process is known as rolling. Next is thread rolling. External threads can be made using this process. See, external thread can be made using this process. These two are die, and this is the workpiece, and this is work rest. The force is given through the work rest, so that this workpiece is rotated and moved through the cylindrical die, and that would give the workpiece a in external thread. So this is thread rolling. Next is rotary tube piercing. In rotary tube piercing, what happened? There is a mandrel. That mandrel moves the material. That mandrel remove the move the material stock towards the edge, and what happened? And a seamless pipe can be made. So in the rotary tube piercing or roll piercing, the process is these two rolls are move or these two rolls uh, rotates in opposite direction, and uh, while moving and the workpiece is also rotated while progressing through the mandrel. So that is roll forging, rotary or tube piercing. Now we will see some of the mathematical terms. Those are important for our rolling. So first, see see how the rolling is done. So first, there is this is our first roll, and this is our second roll, and now this is our material stock. Now this material stock, there is three or four things that should be known. First, the contact length. At a instant, how much length is in contact with the rolls? This much. So this is known as contact length. The angle, this angle from the center, this angle is known as contact angle, and the thickness here is the strip thickness before, that is H0, and the thickness here is the strip thickness after, that is HF, and the friction in between the roll and workpiece is mu. Coefficient of friction is mu, and r is the radius of the roll. Now we will see some terms. That is, first one is maximum possible draft. The maximum possible draft is the maximum possible difference or maximum possible reduction between initial and final strip thickness, that is given by H0 minus Hf by mu square r. In the term of angle of contact, that is given by H0 minus Hf 2r 1 minus cos theta, where theta is our angle of contact. Now required force is given by, that required force for rolling is given by F is equal to LW Y average. Y average is the maximum permissible stress. Is Y. And now, as we know the force, we can know the torque, and that torque is given by force cross contact distance, that is F cross A, where A is taken as half of the contact radius, half of the contact length, that is half L by 2. Now power is given by P is equal to 2FLN by 60,000, this much kilowatt. This is the expression for power, and that contact length L is given by R root over of R H0 minus Hf. This is the contact length. Now, according to this, we will see a problem on depending upon these formulas, and these formula derivation for these formulas are not so important, but you should know about the formula, and you should know that what is contact angle, what is our contact length, and what is the value for those. So I think you had got the idea about that. Now we will move to the rolling defects. The rolling defects, there are several type of rolling defects. First, there is surface defects. such as scale, rust, scratches, pits that are caused by impurity or inclusion. Those type of the defects we will not discuss here. Are those are the the surface defects such as scales, rust, scratch, pits. This type of the defect are caused by impurity inclusion means whenever impurity is included in the stock, that time this type of the defect occurs. But these are not directly the rolling defect. The direct rolling defects are fast wavy edges. These type of the wavy edges can be seen. See, these wavy edges can be seen due to what? Due to roll bending. That means while working, if the rolls bend like this, due to this roll bending, what happened? The wavy edge defect can be shown. Next, there is cracks. There is two types of crack. First, there is zipper crack. This type of crack, this is called zipper crack. Zipper crack is due to low material. Means whenever the material in the stock is less than the required material for the forging for the rolling process, then this type of crack can occur. Next, rage crack. This type of crack is known as rage crack. This is due to lack of ductility of the in the material. This rage crack is due to lack of ductility in the material. Next is alligorating. That is, alligorating means due to non-uniform bulk deformation. If the material is broke into two strips like this is called alligorating. So this alligorating occurs due to non-uniform bulk deformation in the material. So these are the rolling defects. Now we will see one problem, that is, see what is the problem statement. First, the problem statement will be analyzed. So problem statement is an annealed copper strip, or say copper strip of 28 width and 50 thick is rolled to a thickness of 20 in one pass. That is given. And the roll radius is 300 That means R is also given, and the roll rotates at 100 rpm. That means the N is also given, and average stress is 180 MPa. That means Y average, that is also given. So first we will to determine the force and power required. They want compute the force and power required for calculating the force. What is needed for calculating this force? F is equal to L W Y average. Now W or width and Y average, these two things we know, but this L is the contact length. This is given by L is equal to root over of R H0 minus HF. Now H0, what is H0? First, it is 25 thick. So that means H0 is 25 and HF is 20 So R is equal to H0 minus HF. L is equal to root over of R into H0 minus HF. Putting those value, what we got? We got L is equal to 38.7 Now putting this value in meter. We are changing millimeter to meter. So in meter, by changing the value, we have got this expression of L is equal to 38.7 by 1000 and W is equal to 228 by 1000 into 180 megapascal. That gives us 1.74 meganewton. That is the force required for doing such type of rolling operation. for getting this type of reduction in single pass. Now the power requirement is given by 2 pi FLN by 60,000, this much kilowatt. Putting the values here, we got 0.705 kilowatt, that gives us 705 watt. So this is the result, these two are the result. So this type of problem may come to your semester. So that's it for today, and I hope you enjoy the lecture, and if you have any problem you may ask me on the live class. Thank you.